head back here. First of all, because our integrating is the inverse of our derivatives, we're going to kind of take a look at the derivatives of these main three, which you probably already know. Let's split this. Let's split this. And this one I believe we did last week. So what's the derivative of arctangent? You know, it's 1 over 1 plus x squared, had this been an x, right? When it's a u, it's u prime over 1 plus u squared. That's its derivative. Or I like to write it better because when you see it as an integrand, having the du pulled off like that instead of u prime over kind of sorts it out a little better. I think I derived that one last week. But I want to derive the other two just so you kind of remember where it comes from. So let's go on here and go through the process of the derivative, because obviously if you integrate this, then you go back to that. So it's good to be able to spot that form. So let's suppose your original function was y, and it's arcsine u. And I don't like arcsine, so I'm going to get rid of it. So both sides, I'm going to do the sine. So we did one of these last week, so it should be in your head. So that will equal just u, or think of it as u over 1. So the sine of some angle has to actually be u over 1. So it goes back to our right triangle trigonometry, where my angle is y, right? And its sine is u over 1. So where do I put the u? Opposite. Where do I put the 1? Hypotenuse. And then I use the Pythagorean theorem to go get the other side. So you can kind of think of this as x squared plus u squared equals 1, right? So 1 minus u squared equals x squared. So this is going to be the square root of 1 minus u squared. Correct? So now when I go back up here, my goal is to figure out what y prime is. So when I go up here, I take the derivative of both sides, right? So when I take the derivative with respect to u, technically, of y, sine y, what's the derivative of sine? Cosine. So I'll write cosine y, but remember, this is a chain rule problem, so it's really cosine y times y prime is equal to, you don't know what u is, it's some function, so we don't write 1. That's if it was derivative of x with respect to x. This is where we write u prime. All right, so in order for me to figure out what the derivative is, because that's the original thing, is what's the derivative of arcsine, we would get u prime over, now go back up there, what's the ratio for cosine? Adjacent over hypotenuse. So when I divide both sides by cosine, my adjacent over my hypotenuse is just 1 minus u squared. Do you need to know how to derive them? Absolutely not. But it helps them get in your head, and in the event that you forget, it's kind of nice. So we're going to go over here and do arcsecant similarly. So let's go, again, we have time to show you where stuff comes from in here, and I think that really enhances your understanding. That the wild card FRQ I gave you on the test, national average was 4.3 on it. You guys averaged 6.7. So I think it does help to kind of, even though you didn't feel like you were using all the revolving solids and derivation stuff, it gives you, like, I think, a deeper understanding. So let's go take a look. What would I do first on this one? Secant. Yeah, let's get this out of my inverse trig function. Let's just say secant y would be equal to u or u over 1. And then we'll go make our little triangle and decide where to put the u, right? So secant is the inverse of cosine, right? And cosine is adjacent over hypotenuse. So what's secant? Hypotenuse over adjacent. So u goes here, 1 goes here, and then again, if you're looking for this one, it'd be 1 squared plus it squared equals u squared, right? So you'd subtract 1 and take a root. So this actually has the u squared first over there. And I'm just Pythagorean theoreming it because you guys are smart enough to do that in your head. All right, so now I'm back to the original. I now need to take the derivative of the left-hand side. What's the derivative of secant? Secant tangent. So I'm going to say secant y, tan y, times derivative of the guts is equal to the derivative of u, which would be u prime. So on the left-hand side, you're going to divide both sides by secant y tangent y. And let's go see what we get up here. Secant is hypotenuse over adjacent, correct? So there's a u down here. It's actually the absolute value of u because you can't have a negative hypotenuse. That's neither here nor there. Don't worry about it. What's my other one I need? Tangent. How do you do tangent? Think of TOA. Opposite over hypotenuse. So there's a root u squared minus 1. So those are all the derivatives. And then I'll talk about which ones you absolutely need to recognize. But we're going to put them all on here. Look at this little sentence right here. The cofunctions. Cosecant, cotangent, right? And cosine, what did I say they are? Read it. They're just the opposite. So they have the same derivations, but a negative comes into play. So if we were to kind of go like this, let's go throw these on here. Let's put tangents on here first. How do I want to write this? The derivative, let's just do, I don't want to write the whole thing out. Derivative, let's do it with respect to x of arctan u is equal to u prime over 1 plus u squared. It's the nice one without any root. That's supposed to be a u. I don't know. My pen got kind of wackadoodle. So cotangents is going to be what? I'm just going to write co over here. What's the derivative of cotangent going to be? According to what I wrote. Negative that. Yeah, so can I just write the word co up here so I don't have to rewrite it? It's going to be that. Cotangent's derivative is just the opposite. And again, let's go right here. Sine's derivative, maybe you already remembered it. They all have u prime on the top, right? Sine's is ugly. What's on the bottom of it? A root. And the 1 comes first, and it's 1 minus u squared. Cosines is identical, except there's a negative. You could derive them the same way. The only thing is when you do the derivative of sine, you get cosine, but cosine you get negative, so that's where the negative will come into play. They'll have the exact same. I'm not going to drive all 6 of them because I'll drive you. That'll make you really grouchy. All right, so that's cosines. And then you can go ahead and you can write the secant one on here. These really are the only two that AP has. So we're going to focus on those more. They're all kind of just formulaic. So if you can do these two, you can do all of them. And again, cosecant is just going to be the negative of secant. So it'll be negative u prime over u square root u squared minus 1. All right, so there's the derivations and there's the derivatives. We are going to be working with the integrals. So if you look on the next page here, it says these are the ones you must recognize. This one, not even as much. Usually these two. So any integrand that's in this format, somehow when you integrate, you're going to get an arc function or an inverse function. And here are the two you have to know. My son just took a test on this in college, and he said that his teacher just put all 6 of them up on a little sheet, and they could just use it. We're not going to do that. Why not? Why wouldn't I just give them all and have you have a little slip that you could look at? If I did teach it at college, I would. But for the AP exam, you can't use a little sheet, but they only test you on the main 2. So I'm going to make sure you can use the main 2 really well without a cheat sheet. If so, you could do all of them if you had a cheat sheet. So we're going to focus mainly on arcsine and arctan. I like to call it arc instead of inverse, so you'll see me switching notation a little bit. But we're going to start off with the easy ones, so go ahead and write easy. These are easy peasy. Tend to pop up on multiple choice every once in a while. Don't send. All right, so these right here are easy level, but first of all, this is kind of what you need to do. If you take a look at this, It doesn't only apply when there's a 1 here. What does it say it applies when there's a what? Anything squared. So what this is saying, let me just, so you can get an idea. First of all, I like to do this, and I like to put my du over here. I just think it sorts it out better. I don't like this notation. But if that had been 9 minus x, you should recognize that as being sort of arc-siny. What would be your a? 3. What would be your u? Oops, that should be squared. What would be your u? X, right? What's the derivative of x? What's the derivative of x? 1, okay? So this is saying this is just arc sine x over 3 plus c. So your process is really identify a. Let's go write that down. First thing, identify what constant is being squared. If it's 1, super, super. If it's not, identify it. Okay, so you're going to identify the a. Number 2, you need to identify the u. So whatever's being squared, remember u is some function that's being squared. It's not always x squared. All right, so you're going to identify u, but here's the kicker. If you're not listening, tune back in. This is what causes mistakes. Once you identify your u, make sure you also identify du. Because this does not say dx over. It says du over. So you're going to be off by a fraction. You're going to go look at the key and go, oh, I got 1/8. They got 1/16 out front. And it's probably because u was 2x. So you had to, you see what I mean? And you probably forgot this part. So star that. All right, when u is just x, then it doesn't affect things because it's just a 1, so we're good. Like here, right here. That's why these are easy. All right, number 3, you're going to use those. And if you really, really have extra time, you can always check. How can you always check? Any integral. Take a derivative. All right, so let's go up here. This one shouldn't require any work. It's got a is 1. U is x, and what format is that? Arcsine or arctan? This is arcsine. Yeah, so on this one, my a is just 1, my u is just x, and my du is just 1 dx. So this is simply arcsine. Let's go write that. Arcsine u over a. So it's really just arcsine x. That one's easy. What did I forget? Carl. Because it's integrating. And that one's just nice and easy as it could possibly be. Now, you're going to find yourself, how am I ever going to remember this? Last year, we decided that u over a is urine analysis. And it's 1 over analysis, urine analysis. This one's just urine analysis. So the tan has the a in it, so it's got an extra a. So it's 1 over analysis, urine analysis. Because you got to remember it at some point without looking at it. Sine doesn't have the a, so there's no 1 over a out front. So just think urine analysis. What are you going to think? Urine analysis, but tan has an extra a, so it's 1 over analysis, tan inverse urine analysis. It's stupid, but it sticks in your head, so you won't be going, what is it, and having to look, because you won't have this. All right, so let's go take a look at this one. This is also in the format of arcsine. My a is actually what on this one? 2, my u is x, so my du is just 1 dx, so no worries, right? So this is simply, again, arcsine, urine analysis, plus c. Done. Right? The next one's super easy, too, because it's all set to go. What's the next one? Arctan, x. Yeah, your a is 1, right? And you might say, do I have to write this out? You don't. But when they get harder, that it's going to get you going. But my u is just x, so that's just arctan x. All right, I'm plus Carl on all of them. Let's bump it up a little bit. So one of the dangers, too, is now you're going to think they all get done this way. So your go-to is always to look for u sub first. Always look for what first? U sub, because some things look triggy, but they're not. So on this, I take my normal approach. Let u be this. I get negative 4x dx. There's no x on the top, so u sub will fail me. So I kind of see that this looks a little arcsine-y. But 5 doesn't look like something squared, and I tell you it actually is. What is it? Root 5. Yeah, so your a is root 5. Your u is whatever's being squared to get 2x squared. So what's u? Root 2x. Okay, so be careful because this actually is a squared, 5, u squared is 2x squared. But what did I tell you about the u? You have to do du because in this case it's not 1. So you're going to write, well, this would imply, right, or let's move right below it or indent a little. What's du? Root 2. And it's actually du dx is root 2, but we put the dx over here. So really, if you think of it like this, 1 over, I'm going to write it, and I'll give you a break, which I like to. I like to pull that dx off to the side. My dx, when I replace it and make it du, is really what? 1 over root 2 du. Exactly. So let's write that. That dx right here, just like we've always done, 1 over root 2 du. So we've got to be really careful. When I set it up, this is what I've got. Like, I'm going to write this one out in full. I actually have the integral of 1 over, right, square root. I did have an a squared minus u squared, but I had a 1 over root 2 du. So again, you don't have to write that on every problem, but I want you to see what's happening. Now that you've sorted it all out, is this arc sine or arc tan? Arc what? Sine. It's the uglier of the two. Arc sine is just urine analysis. So this is just that fraction correction. Arc sine, u, what's u? Root 2x over a, what's a? Root 5, right? You could clean that up and get the radical off the bottom if you want to. I'm not going to. Okay? And then don't forget about who? Carl. So you do kind of have to have a system. The next one, again, it looks similar, but it's very different. How is the number 5 very different? This is u sub. Yeah, so I'm just going to write, because u sub results in a du being a multiple of the top, that's just u sub with a what fraction correction? Negative 1/4. Do I need to go through with that one? I'm just going to put eyeballs on it and make sure you notice that that's going to be a negative 1/4, 1 over root u du, and you should be comfortable working that one on out because that's nothing new. U sub is king. So look at number 6. You might be seeing things squared on the bottom, but actually you're not, right? E to the x isn't something squared. What is number 6 going to entail? U sub. Who's u? 9 plus e to the x. What's du? The entire top. Yeah, so this is really the integral of 1 over u du. There's my u, and the rest of it is du. It's perfect. What's its antiderivative? Do you remember? ln, exactly, Aaron. So this, again, just because we're in this section, don't get in lockdown on it because, honestly, most things can be done with u substitution. So that's a nice natural log. All right, we're moving on. The next one. Again, your go-to is always u sub. You get negative 2x. You've got this x plus 2, and this one should stump most of you. So I'm going to wait for somebody to maybe give me an idea, because I am seeing something arcsine down on the bottom. And had that just been a 2, I could pull it out front. I've got 1 over a squared minus e. It's ready to go. But that's screwing me up. If you have a plan of attack, break it apart. Excellent, Sully. When you're over a single lump sum, and it kind of looks like it could be a heart with a singular term on the bottom, you can break it up. So let's go do that. So you're going to make the first part x over root 4 minus x squared. You're going to make the second part plus 2, but I'm actually even going to pull that constant out front. And now I've got 2 integrands that I can do, but they're done separately. They look the same. Which one is an inverse function, the left or the right? The right. Which one is it? Arc sine. Yeah. So remember, it's going to be 2 arc sine u over a. What's a? 2. Okay, that's this part. That's arc sine, and the du is just 1, so I didn't even have to throw another fraction out front. This one over here, what's it going to be? How am I going to tackle that one on the left? That's u sub. Okay, and it's going to be u as the bottom. Can I not finish it? Just so, because my goal isn't to rehash u substitution. This is a nice easy u sub, 1 over root u, right? Negative 1/2 du, so you're going to have a fraction correction. But I'm just going to write u sub e, all right? So you can see breaking it apart is helpful. So on the next page, there's one I want you to do on your own, and then we're going to tackle that bottom one in a minute. I don't know if I wrote that bottom one how I want it. So go try the one on the next page. We'll do one more together, and then we are done. I have a feeling. Raise your hand when you have it. Then your worksheet's just 10 inverse trig function ones. It's pretty straightforward. Just pop up a hand when yours is done. One of the biggest struggles with people in calculus at higher levels is how do I know which integration technique to use? You don't. And if you try one that doesn't work, you try something else. That's just how it goes. But this looks kind of arctangent-y if only, right? I'm going very fast. I hope I'm not making a mistake. You guys can. Anyone done? Is it a match? Okay. I was kind of thinking about things while I was writing very fast. My brain wasn't fully involved. So hopefully you're close to being done. But when you look at this one, all techniques kind of fail you. The derivative of the bottom is 2x. That plus 2 is screwing you up. But this looks very arctany on the bottom. It looks very a squared plus u squared, right? The problem is the top. So the first thing I did is I separated the top because this is a nice, it'd be this over that plus this over that if I were to separate the fraction. So this actually came out really nice. You really have to be careful though. Where did this come from? If you stare at it, I just put a check mark by that 1/2. Where did that come from? 1 over analysis, right? That one had Where did it go? It had an A of 2. So it's 1 over analysis, arctan urine analysis. This 2 came from the original problem. So these do end up canceling out. So that's where that came from. And then this went to a nice U sub of 1 over U, and it's good. How many of you had it right or were well on your way? Okay, we're going to bump up the difficulty one more time, and then I think I'm just going to let you go to work because this is very structural and it's very algebra. If Emma were here, she would love it. This is the exact stuff she likes, but she's not here. But I'll give her a shout out in my earphone. All right. This is you do them all the same way, and as long as you don't make an algebra mistake, you should be pretty good to go. I know I'm going to have you add that one, and I believe I forgot a root on the bottom of it. I picked one off your worksheet that was a little bit uglier. Yeah, this should have a root as well. Otherwise, it's not looking as I want it to. So go throw that either on the bottom of the page you just did, probably is easier. So on one like this, your original go-to is U substitution. Even though on your worksheet today, they are all arctan or arcsine. But in the grand scheme of like an AP exam, that's not, you have to go U sub first, negative 4W cubed, crap, not on the top. So you need another tack. When you look at the denominator, it looks very what? Arcsine. That's not a word, but you should be thinking, oh, that's the ugly with the something squared minus something squared. So we go through our steps. We're going to identify our A. We are going to identify our U, right? And this is weird because it has a W in it, and you're used to X's, which is exactly why I chose that. Who's U? W squared. Exactly. So before I move on, what do I need to do? DU is 2W with respect to W. But that's not what I want here. So this is going to have just a 1/2 du going in for your W dW right here. So you got to be really careful that when you rewrite it, because this is what people forget, okay, in this process. So what I've really got going here is a 1/2, right, the integral of, and let's go take a look at what I've got. I would have 1 over square root, and I'm rewriting it all so you can see it, a squared minus u squared, and this was all 1/2 du. Now it's ready to rock and roll, right? Which trig function did you say again? Arcsine. Yeah, so this is going to be 1/2 arcsine, or sine inverse, I like arcsine, urine analysis. No 1 over a required, but if this was a tangent one, there'd be a 1/3 also, so watch out for that. So this would be u over a plus c. Now you remember how I told you can check them? You can, but they're kind of ugly to check by taking the derivative, but I am going to check just this one, just so you can see and trust the 1a over u, or just so you can trust it. All right, so watch. If I were to take the derivative of this, and you don't need to write it down, just watch. The 1/2 won't affect anything, right? The derivative of arcsine is u prime. All right, what's the derivative of w squared over 3? 2/3 w. Okay, that's the u prime over the square root of 1 minus whatever's in here squared, right? And so that'd be w to the 4th over 9. And you might say that looks nothing like the original problem, LaRude. Watch. Gone, gone. Right? Are we good so far? So I really have a w over 3 from here and here. On the bottom, when I clean this up and get a common denominator, that's 9, because I'd have 9 over 9. You watching? So that's 9 minus w to the 4th over 9. There's my 1. You see what I did? Are we good? And it's under a root. But what happens when I take the square root of this 9? And that's the original integral. So do you see how it did work? You just wouldn't want to check them because the checking's worse than the doing, but I wanted you to see it work full circle. All right, we are done. Your assignment is